displacement. What letter did we use for displacement? Good guess. What letter was it? There's a different letter. Look back in your note. What is it? We had a certain letter that we used for displacement.
X.
X. So displacement is X. And then to go from displacement to velocity, which is another way to do it, is X with a 1 dot. Okay, what do we do? Okay, so we differentiate. I'll just do that. Then to go from velocity,
Differentiate it again.
acceleration,
Oh yeah, and differentiate again.
we differentiate again. What we're going to do today is go the other way.
Integrate.
So to go the other way, we integrate. Integrate. So that's exactly what we're doing. We're going in the reverse way. So we integrate from acceleration, we get to velocity. We integrate velocity, we get all the way back to displacement. And that's what we're looking at. Okay, which is exactly what this tells us here. Taking the primitive of a function, in other words, integrating, always involves an arbitrary constant. Remember our C's, we're going to do plus C. And then you're often given a boundary requirements like the initial amount. Henry, you ready to listen?
Yes.
Okay. To help us find what that constant is. So, let's do A. The velocity of a particle initially at the origin is this. Find the displacement function. So to find the displacement function, I'm going to need to integrate. Okay. So x, because that x is what I use. Well, it's going to, when I integrate it, it's going to be a cos. It's going to be a negative. And what's the coefficient going to be? 4. Why is it 4, Ben?
That's the rules.
Is the rule, okay, you do 1 over whatever the coefficient of the variable is in there. Okay? But I must do plus C. The velocity of a particle initially at the origin. Now tell me, the displacement is originally at the origin. So what is the displacement originally? 0. So when time equals 0, what's the displacement? 0. Okay, so we have 0 equals minus 4 cos quarter times 0 plus C. What is cos of 0? 1. Did I hear someone say 1? It sure is. So here we have 0 equals negative 4 plus C. So in other words, C equals 4. So now I can write my displacement properly. Therefore, displacement given by minus 4 cos of a quarter T plus 4. Because 4 is my constant of integration. It then says find the acceleration function. So what will I use? Will I use my displacement one or my velocity one? Velocity, and what will I do to velocity? Differentiate. We're getting good at this. Okay, so we need to find the acceleration. So we are going to differentiate this, which becomes a quarter cos T. Oh, sorry, I needed a quarter in there too. Okay, so there's my acceleration function. It says find values of displacement, velocity and acceleration when t equals 4 pi. So we're just going to sub in t equals 4 pi into each of our functions here. So displacement, well, x equals times cos a quarter times by 4 pi plus 4. What's a quarter times 4? Just 1. So this is minus 4 cos pi plus 4. Do you remember what cos is at pi?
0.
-1. Thank you, Amy. It is -1. So this is -1. So -4 times -1 is positive 4. And positive 4 plus positive 4 is 8. X is 8. You could, of course, have put that straight into your calculator. Alternatively, the next one. So we found displacement at that time. Now let's find velocity. So we've got our velocity up here. Velocity equals sine t, and in fact, instead of t, I'll just write, I know t is 4 pi. So in other words, this is sine of pi, because a quarter times 4 is 1. Sine of pi. What is sine at pi? 0. Thank you. It sure is. The velocity is 0. And acceleration, well, quarter cos quarter times by 4 pi. A moment ago we talked about what it was cos at pi again. -1. -1 times a quarter, so we have -1/4. There's one last thing I would like to put in here. I would like to put in units. So what units do we have? Well,
Something.
are we given any units at all here?
No.
This particular one, we are not given any whatsoever. Usually, we could assume that it would be meters and seconds. This question doesn't state. Most questions will give you units. But I want you to get used to what the units would be. So I'm going to assume it's meters and seconds, okay? So what would my displacement be? So I know it doesn't say that, but let's just make a little note. We're using meters and seconds. Okay? So what would the displacement be? What would my units be for displacement? Meters, it sure is. What about velocity? Velocity is meters per second. And what would this be?
Meters per second.
Meters per second,
Or meters.
or meters per second squared, or meters per second to the negative 2.
Meters per second.
Okay?
Briefly describe the motion.
How's that? We're all good with that? D. I want to leave all of that up there, so I'm going to come over to this side. And the next part, so D says, briefly describe the motion and sketch the displacement time graph. I think it would help if we did the sketch first, so let's do that. Before we sketch it, let's just, on the side here, let's work at the period. Period for any trig function, well, for cos and sine is 2 pi over b. What is b in this case? B is always a quarter. So the period is 8 pi. So it takes 8 pi to do that. So we want the displacement. So we're going to do this one. Okay. The next thing, what's the amplitude? Well, yeah, so -4. So it's going to go, you'd think it would go between what? -4 and +4, right? So between -4 and +4, but the whole thing has been shifted up for what? So now it's not from -4 to +4, the whole thing shifted up and it's between 0 and 8. Is that clear? Okay, so we want to go all the way from 0 and it's going to go all the way up to 8. Or in the middle, the 4 would be what you normally have 0 be. Okay? Cos. Well, what does cos start out at? When, sure?
Miss.
Starts out at 0. Because it's not what it would normally, cos is normally. Cos is normally starts out at 1. But you're absolutely right because -1, we've moved everything up, the amplitude is up, and at this point it is exactly starting here. Just absolutely right. So it's coming up and it's doing our curves as it always does. Now, we know that the period is 8 pi. So right here is going to be 8 pi. When it reaches its peak there, that's going to be 4 pi. That's obviously down. When it comes back down, that's now going to be 16 pi. And here it will be half in between that, 12 pi. Okay, now I think now we can get a bit of a picture about what's happening. So the particle begins at the origin. Then what happens to it? Is it moving to start with?
What's the
It's
axis?
officially at rest because the velocity 0.
What's
The
the-
axis, so this is displacement, this is time. Thank you, I should have had that on there.
Where did you get the, for B, where did you get the quarter from?
A quarter. B is your coefficient of whatever the
Okay.
variable is inside of the trig function. Which normally you're used to that being x, but now we're talking about that as being t.
Why isn't the displacement just represented as y?
That's a really good question. I asked the same question, so I don't have a really good answer to that. Maybe someone does. That would make a lot of sense, but
As
for
in like-
now,
Yeah.
it would make a lot of sense if we kept it to being y. Sorry, I know it's confusing. I think we can do it now. I've got confidence in your ability. Yes.
X equals -4 times cos.
Yeah.
Shouldn't that make the graph flip though?
Yeah, it does. Absolutely, it does.
Oh, you didn't already.
It actually is already flipped, believe it or not. Because it would normally start up here and go down, and let it down. But now it's actually started down here and gone up. So yes, good questions. Okay, so the particle is originally at the origin at rest. I didn't actually draw that very well because it should have been as part of the curve and it comes up like that. So it actually is the acceleration or the gradient at that point is 0. And it's at rest, which meaning that the acceleration or velocity there is 0. And then it begins to move to the right. It's moving away. Right oscillating between 0 and 8 and it's at the period of 8 pi seconds. So it begins to move to the right and oscillates between x equals 0, so the displacement of 0 and x equals 8 with a period of 2 pi. a moment to copy that down. I'll write this down while we go. Are we ready for example 2?
Yeah.
I think we are. So the acceleration of a particle is given by this. So it's e to the negative 2t. And the particle is initially stationary at the origin. Find the velocity function. Okay. Velocity function, so what are we going to do? Are we differentiating or integrating this time? Integrating, we're going backwards. Okay, so the velocity function, or you can say v, whichever you like. We need to integrate this. Well, e to the negative 2t will stay there. And then it will be negative a half.
I equals.
Yeah, because you do 1 over the coefficient. I'm missing something though. What am I missing?
Plus C.
Plus C. Thank you. Plus C. So I know that it's initially stationary. Okay, if it's stationary, tell me what the velocity is. 0. Okay, so when initially tells me that t is 0, stationary tells me v is 0. So when t equals 0, v equals 0, and let's just sub that in. So we have 0 equals minus half e to the 0, because minus 2 times 0 is 0. Plus c. What does c have to be then? Well, that's just a half. So that's minus a half plus c. So then c, I'll come up here, c equals a half. So therefore my velocity graph, or my velocity equation I should say, is minus half e to the minus 2t plus a half. Now it says find the displacement function. What do I need to do again? Sorry? Sure. So I've been at acceleration. I've now integrated back to velocity. I need to integrate again now to find displacement, which is an x. And that x is now going to be quarter e to the minus 2t plus half t plus, I'm going to use a different constant. I'm going to say d because I don't want to confuse it. It's in the same question. And we've already found c, so it doesn't make sense to say c again. So I'm going to use d. Okay, so how I got this is I just multiplied minus half by minus half again, which of course gives me a quarter. And then integrate that, you have to add the variable t. So there we have it. So that's the displacement function. Well, almost. Initially, it's stationary and initially it's at the origin. What does that tell me? That tells me that when t is 0, displacement is 0. T equals 0, displacement equals 0. So let's just sub that in. 0 equals quarter, 0, plus half times by 0 plus d. Well, that is just a quarter. That turns to 0, so quarter plus d, so d then must equal negative a quarter. Okay, negative a quarter. So now I can write over here my final displacement function is x equals a quarter e to the minus 2t plus half t. And I now know that my g is minus a quarter, so I'm minus a quarter from the end. Any questions from that so far? Want to leave all that there? And I'll do C over here. So part C says, find the displacement when t equals 10. Oh, that's nice and easy. I just sub in, and t equals 10, I just sub in 10. And it says to find the displacement. So I'm going to use my displacement. Formula for x equals a quarter, e to the minus 2 times 10. Plus half times 10 minus a quarter, which is a quarter e to the negative 20 plus 5 minus a quarter. I could simplify that. 5 minus a quarter, that's going to be 19 on 4. Because 5 is going to be 20 on 4, 20 on 4 minus 1 over 4 is 19 on 4, so you have 19 a quarter e to the minus 20 plus 19 on 4. Our displacement, once again this question does not give us units, but we're going to once again assume it's meters and seconds because I want you to get used to writing meters and seconds. So we're going to assume that this is displacement, so what will my units be? Meters, okay. So D. Part D says, briefly describe the velocity of the particle as time goes on. Velocity. So we've got to go back to the velocity function and describe what happens. So let's consider endpoints. So when t equals 0, what's velocity? V equals 0, okay.
Oh, right. I thought you were showing the answer. Should be half. No.
What about when t approaches infinity? What happens to it over time?
It's exponential.
Okay, here it is. As t gets bigger and bigger and bigger here, what's this part get closer to? 0, you're absolutely right, because a
I guess.
negative exponential is going to be like that.
I thought it'd be there.
Okay, so it's going to be like that, so it's going to get closer to 0, but that would have been if it was
Wouldn't
just
it
that
be-
part.
Yeah, okay.
Because it's now got a negative in the front as well, it'll then be like this. Okay.
Yeah.
But you're right, it gets closer and closer to 0.
Ah.
Always getting closer, closer, closer to 0. Okay, so all of that is closer and closer to 0. But then it's got plus a half. So as we're going bigger, getting bigger and bigger and bigger, it's approaching, looks to me, it's approaching half. So V approaches to half. So, the velocity t is initially 0 and approaches a limit of a half. ask you for a graph. But if we were to graph it, it's 0 to start with. This is a half. It gets closer and closer and closer to a half, so it's going to be something like that. But it didn't ask for that. And this is velocity, by the way, and time. Any questions about that? That question, once again, it doesn't say what the units are, but if we assume meters and seconds, it will be a approach the limit of a half meters per second because it's the velocity is in meters.
We'd say, like, describe it a little in more depth in the sense like exponentially or something like that. Approaches a half exponentially or.
Yeah, you could. Oh, no, it's not exponentially. Hang on, what am I saying? Exponential would have to be this.
The other way around, yeah. But is
It's
there like
going that
different
way. I can't think of a word to
terms?
say that.
Okay. So it's just approaches
Yeah.
a half.
Just say that. That's
Okay.
all really you can say. I would love to just do one last question. So, gravity. Physics guys, I'm sure you know all about this.
Yep.
Let's do one application where we've got gravity involved. And then we'll leave it for here for today. Okay, so we know since the time of Galileo, it has been known that near the surface of the Earth, a body, accelerates downward at a constant rate, whatever its mass and whatever its velocity. And of course, we're just not talking about air resistance and all those other things just at the moment. The acceleration is called acceleration due to gravity, okay? It's normally given by the symbol G, and this acceleration is about 9.8 meters per second squared. Is that the figure that you use? Physics? Great, okay, so that's what it is. Or in round figures, we can say it's about 10 meters per second squared. So let's do one example. A stone is dropped from the top of a high building. How far has it travelled and how fast is it going after 5 seconds? Now when it says how far, what does that sound like to you? Oh, okay, that sounds like displacement to me too. How fast, what does that sound like to you? Speed, yep. Speed, velocity, yep. Fantastic, okay, so we take that G is 9.8 meters per second squared.
So that's acceleration.
There's one little statement I do want to just put at the top here, and it's so we're going to have x be the distance travelled to t the seconds after the stone is dropped, and downwards we're going to consider downwards to be the positive direction. Okay, does that make sense to us? Why is downwards positive? Because, well, that's what happens most of the time, okay? It falls, it shouldn't go the other way. If it went the other way, that would be considered negative, okay? So, let's write all that down. Let x be the distance from the top of the building and t be the time after the stone is dropped. And we're going to let downwards be the positive direction. Let downwards, yeah. Be
instead of writing in words flat, we just do like a sort of like an arrow and then positive.
No arrow.
It's like like so see how like the diagram has
Oh yeah.
that and just put up a positive sign next to it. Just say it's
I guess so.
positive.
Okay.
Put a bit more.
So G is 9.8. G using what we've been doing so far. G is what?
Acceleration.
Acceleration. So in other words, the acceleration equals 9.8. Okay. So what is? We should go back to velocity next. What will velocity be?
9.8 T plus C.
Will be 9.8
T plus C.
T plus C. Okay. What is the velocity at 0? When t equals 0, times 0 it hasn't moved anywhere, it's sitting in the person's hand, so v equals 0. So in other words, v equals 0, 0 equals 0 plus c. So c equals 0. So in other words, velocity equals is 9.8 t. Over here then I will do displacement. X, then we have to go back again. So what will this be?
9.8 T squared over 2.
Over 2 plus
D.
d, just because it's a
Okay.
constant. But what is the displacement at time 0?
0.
0, okay, it hasn't moved anywhere at time 0. So when t equals 0, x equals 0, so in other words, 0 equals 9.8 times by 0 squared over 2 plus d. In other words, 0 equals 0 plus d, d equals 0. Hence the displacement is simply 9.8 t squared over 2.
Let me just substitute 5.
All we have to do now is substitute 5 into this. Okay, go to do it over here. Myself a bit more room. When t equals 5, please remember, even if you can see that the constant is going to be 0, please show that. Because a marker doesn't know that you actually had remembered that there should be a constant and that you'd done that mental check to see that it was 0 in your head. So we don't have like a little printout of what your brain was thinking at the time to give you marks for. So please just make sure that even if you see it 0, you actually demonstrate that it is 0. Okay, how far and how fast? Okay, so how far? So x equals, well actually I could make this even simpler, couldn't I? Half of 9.8 is, it's going to be 4.9 t squared. So x is 4.9 times 5 squared. Ethan, can you put that in your calculator? V equals 9.8 times 5. Someone else? Kai, do you want to tell us what that one is? What, sorry? 49? You're right?
Yeah.
49, and it's meters per second, and this one was? 122.5 meters. Okay, and that's all it says to do, isn't it? So we could just make a statement is 120 meters dropped, has dropped 122.5 meters and is travelling at a speed